Hi, this is Dominic, and I will be doing a practice problem from limiting reagents and percent yield practice worksheet. I got number 1, and as you can see, I've already balanced our equation. We had the question was when copper 2 chloride reacts with sodium nitrite, copper 2 nitrite, and sodium chlorite are formed. So I did that. I balanced our equation, and time to start on step B, which was if 15 grams of copper 2 chloride reacts with 20 grams of sodium nitrite, how much sodium chloride can be formed? So to achieve this, we are given 15 grams of copper 2 chloride and 20 grams of sodium nitrite. So the first step is, since we are given 15 grams of copper chloride, I will start with this. We are going to want to get into moles, which is like that. And then we'd need the molar mass of copper 2 chloride, which I have right here. It is 139 or 4, sorry. 134.45, which is our molar mass of copper 2 chloride. Remember when you were doing the molar mass of a compound, if it has a subscript, then you add it. If it has a superscript, you don't add it. That is for something else. And then we're gonna times that by 2 over 1 moles. This is supposed to be 1 mole of copper chloride, or copper 2 chloride, which we know is because its superscript is only 1, and the 2 comes from what we're looking for, which is sodium chloride, which is 2. The superscript is 2, and then we're going to times that by give me 1 sec. We're going to times that by 1 mole and 58.44. That is our molar mass of sodium chloride. You do again for this. It's just, you're not gonna the 2 doesn't matter, so you're just gonna find the mass of sodium and chloride, add them together, and that your answer should, or your molar mass should come out to 58.44. And then you plug this in the equation, and you should get 13.0. And then we have another. So we have another given, which means we have to do it again. Same thing, 20 20.0 grams. Oh, that is grams too. Whoops. Times. So this one's going to be 1 mole. And then, so we need the molar mass of Na nitrite, or sodium nitrite, which is going to be 85 times, again, the mole ratio, which is going to be 2 over 2. We get that by, again, we have that because this is 2 and this is 2, so we don't need to have any. That's where our mole ratio is going to come out to. 2 comes from this, of course, because the mole ratio is whatever we are given is on the bottom and what we're looking for is on top. And then again, you can just use this one again. It's the same thing, because you're looking for the same mass. So you're gonna put 0.44 over 1 mole. Again, this is the molar mass of sodium chloride, and then that should equal to 13.8. So, part C of the question is asking which is our limiting reagent for reaction in part 2, and that is going to be 15 grams of copper chloride. The reason why is because 13 is less than 13.8. So that means that this is gonna run out first, and this is gonna take a little bit more time. So overall, this is gonna run out quicker. That is how you find the limiting when you are given two different masses. Now we are going to, give me one sec. Okay, so I'm going to delete all this. Actually, I'm just going to do this. Whoops. I'm going to just do this. Gonna give it a sec. So our next question is, how many excess reagent is left over in this reaction? If you give me one sec. Is it not erasing anymore? I might not be able to go all the way back, which is fine. I think I have an idea how to clear all of this. Let's see. Let's see if this works. Sorry for the fill. Okay, sorry if so I needed more room to do this. If you need to see it again, just go back to the video, pause it, and then write it all down. Okay, so now we are going to go to, whoops. Now we are going to, okay, so again, E is asking for how much excess reagent is left over in this reaction. So to do this, I would look back to the first two equations, because we are going to find the excess. We're going to use copper. We're going to look for how much the excess radiance gives when it's like being times by copper 2 chloride, which is our limiting. So we're going to start with our limiting. 15.0 grams times, we're going to times it by 1 over 35, or 140.45 times 1 over 2 times 85, which is our molar mass of sodium nitrite. This is the molar mass of copper 2 chloride. And that, if you do it put it in your calculator. 15 times, you can do 15 times divided 134.45 times 2 times 85, or you can do 15 times 1 times 2 times 85 divided by 134.5. Either way, you still get the same method. It's depending on how you want to do it, which will come out to 19.0 grams of Na, sodium nitrite. So now that we have this, we are gonna, sorry for how bad it looks, but now that we have this, we are gonna subtract it from our given. So it's gonna be 20.0 minus 19.0, which will come out to be 1.0 grams. That's how much leftover of our excess has. So that just means it uses 19 grams, so there's 1 extra gram left over from it. And okay, so now for F, it says if 11.3 grams of sodium chloride are formed in this reaction described in problem 2, number 2, what is the percent yield of this reaction? What this is saying is how much, so this reaction goes in real life, and when we finish it, we come out with 11.3 grams of sodium chloride. Now, that is different from what we have. So let me just clear this. Alright, so we have, it says this comes out to 11.3 grams, but this is our actual. If you remember how to find percent yield, it is percent yield equals actual yield over theoretical yield times 100. That's the formula for percentage yield. So this is our active yield, our actual yield, and we already know what our what our theoretical yield should be. It should come out to 13.0 grams, because that is our limited yield, which is going to be your theoretical yield. And then let me you times that by 100, and then so you divide 11.3 by 13 times 100. You should come out to 86.9 percent. That is what you should get at the end of it. So what this is saying that 80% of the actual, or every time you run this, or most of the time when you run this, you will be getting 86% of your theoretical. That is what this is saying. This is what this is for. So we use this just to see how much is actually being lost. How much would be being lost would be about you'd lose about 14.1%. So you're losing about 14% each time you run this. The reason why we are losing this is because molecules get lost to air or other things. And yes, this will conclude the video on how to do limiting reagent and percent yield practice worksheet problem 1. Goodbye.